All right, we're going to start talking about quadratic equations. Up until this point, we've mostly talked about linear equations, graphs that when you plot them on a graph, they make a straight line. When you look at the equations, you can see the slope and the y-intercept, and you know when you graph it, it's going to make a straight line. When you look at the table, the terms are changing at a consistent rate. And quadratics are a little different. So we have some vocabulary here that I would like for you to copy in your notes. Parabola, that's the first word, and it's the U-shaped graph of a quadratic function. Vertex, the vertex is the lowest point on the graph of a parabola opening up, or it could also be the highest point on the graph of a parabola opening down. We're going to see examples of that. An axis of symmetry, the vertical line passing through the vertex of a parabola, or the line dividing a parabola into two symmetrical parts that are mirror images of each other. So we are going to graph equations that are in a different form. Again, notice this is not y equals mx plus b. We do still have one variable, and that is still x, but now we notice that we have x to the second power and we have x to the first power. A, B, and C are constants. That means that they are numbers, they are numeric. So the first graph we are going to plot is going to be y equals x squared. And we have our graph. Make your table, your x values, your input, and your y values, your output. And we like to use some nice, easy numbers, but I would like to have some negatives as well as positives. So -3, -2, -1, 0, 1, 2, and 3. Copy those in your notes. And then we also, when we plug this into our equation, when you plug in -3, what is -3 times -3? +9. That's your output y. When we plug in -2 for x, that means -2 times -2. That equals +4. Okay, and we go left 2, up 4, plot a point. We're going to plug in -1. -1 times -1 is +1. So left 1, up 1, plot a point. And we're going to continue doing the rest of these problems. And look at this graph. You can tell that it is not linear. It is not a straight line. If you were to connect those points, it is not a perfect U. It's like a curved U. Okay, arrows go at the end of both sides of the line. This is called a parabola. Okay, this is called a parabola. So that's the shape of a quadratic. The vertex, in this case, this is a parabola that is opening. Here's your opening. It's opening up, and your vertex is the lowest point, the lowest, smallest value of that graph, and that's going to be 0, 0. The axis of symmetry is where could you fold this in half? So you have a mirror image, and it would be right along the x is equal to 0 line. So x is equal to 0 is your axis of symmetry. We're going to do this again. This time we'll try a different value. We still have our input of x and our output of y. Go ahead and copy those into your problem, and let's substitute. So when -3 is squared, that still is 9, and then 9 minus 5 gives you 4. So we have -3 to the second power, 9 minus 5, and that's going to give us 4. So y is 4. Left 3, up 4. That's your first point. And repeat that. -2 to the second power, 4. 4 minus 5 is -1. So we go left 2, down 1. -1 to the second power is +1 minus 5 equals -4. 0. When x is equal to 0, then y equals -5. Keep plotting the points. +1 squared is 1. 1 minus 5 is -4. We get 4 minus 5, -1. And 9 minus 5, +4. And you draw your last point. And this again is opening up. So we have a low point. Our vertex is right here, 1, 2, 3, 4, 5. So the ordered pair is 0, -5 for your vertex. And your axis of symmetry, like before, is at x is equal to 0. It's where you could draw that vertical line and it slices your parabola in half. So for these problems, I just want you to solve when x is equal to 3, so practice those, plugging in for all 4 problems. This is just practicing with the negatives. I will caution you, be very careful with number 2. The negative sign goes outside of the parentheses and you are squaring negative 3. Hopefully you got these correct. And more graphing, negative x squared plus 4. Make a table, input, output. Notice the same numbers keep coming up because the smaller numbers are easier to calculate. And this was what I was talking about with the previous example. Negative x squared means the negative sign goes on the outside of the parentheses and you are substituting negative 3 for x. So in this scenario, you have to solve the exponent first. Negative 3 squared is 9 times negative 1. This is a negative 1, so you have negative 9 plus 4, which will be negative 5. Locations of negative signs are very important. Same thing with the next one. Negative 2 squared is positive 4 times negative 1 is negative 4. Negative 4 plus 4 equals 0, and so on. And we are graphing as we're finding these values, and hopefully you're recognizing, look what's happening to this one. Okay, this U shape is different from what we had before, and this is a parabola that is opening down. Opening down. So this vertex is the highest point on the parabola. Okay, 0, 4 is the vertex, and we still have x is equal to 0 for our line of symmetry, or axis of symmetry. Try this one, make your table. I bet you can guess which points we're using. It just takes practice. Negative 3 to the second power, 9. 2 times 9 is 18. Negative 4 times negative 3, positive 12. Y is equal to 30. Doing that again for negative 2. Negative 2 to the second power is 4. 2 times 4 is 8. 8 plus 8 is 16. These are larger values. Negative 1 to the second power is positive 1. 2 times 1 is 2. Plus 4 is 6. And now that will fit on the graph. 0 and 0. 1. It's getting there. Last point, positive 3. 18 minus 12 is 6. So it looks like we have a line of symmetry. Your vertex is 1, negative 2. And your axis of symmetry, or your line of symmetry, is going to be x is equal to 1. So notice we have shifted. We were at x equals 0 for several of the previous examples, and now we are at x